This is Advanced Math 12.2 Notes, and the title is Solving Exponential Equations. We're going to solve number 1 is 2 to the x equals 32. 2 to the x equals 32. Now, something like this, some of you can probably do in your head. Does anybody know or can kind of think through 2 to what power is 32? Two to the 4th is 16. 5. 2 to the 5th is 32. And really there's not much work, right? You would just kind of plug it in your calculator until you figured it out, right? Okay, now there's not much work to show here, but I am going to still show some work and tell you what to do because they are going to definitely get harder. Becca, will you turn off one light switch, please? It doesn't matter which one. Thank you. I'm going to write down what it is we're going to do. We're going to have to get both sides, thank you, to have the same base. That's what we're going to do with this lesson. Get both sides to have the same base. Now, I did say it on the previous lesson. When you do that, you want to use the smaller base or smaller. In this case, base 2 is going to work. So I'm going to leave this side to a base 2. And 32 is 2 to what power did you guys just say? 5. And once you get them to have the same base on each side, and as long as there's only one base on each side, you can drop the bases and set the exponents equal to each other. And what does x equal? 5. Now on this one, technically, do you have to show all that work? No, you could just say x is 5. But they definitely get harder than this. This is advanced math. They do get harder. So let me show you what you would most likely see on an assignment or a quiz or even the test. 8 to the x equals 32. All right. Is that something we can do in our head? What's 8 to the first power? 8, right? 8 to the first power is 8. What's 8 to the second power? So is this going to be a nice clean number like number 1? No. So I'm going to have to change them both to a different base. What did I say earlier? Get them to the same base using the smallest number or smaller. What's the smallest number here? 8, but 8's not small enough because 8 to the first is 8 and 8 squared is 64. So there's no way to get 32 to a base of 8. So I'm going to have to go smaller. What's going to work? 2 or 3? Or 4? What would work? 2. I can rewrite them both with the base of 2. Do you guys agree? So what I'm going to do is rewrite 8 with the base of 2. 2 to what power is 8? 2 to what power? 3. And then the exponent stays x. And then I'm going to change 32 to what power? 2 to the 5th. Do you guys agree that 2 to the 5th is still 32? Do you agree that 2 to the 3rd is still 8? And it's still raised to the power of x. So I haven't changed anything. I've changed the way it looks, but I have not changed its value. Does that make sense? Now, what do we do with the power to a power? We just reviewed that. Do we multiply or add? 3 plus x or 3 times x? Times. So this becomes 2 raised to the 3x equals 2 raised to the 5th. And then I just went over it. What do we do once we get them down to one single base on each side that is the same? We drop the bases. and I have 3x equals 5. Divide both sides, what does x equal? 5 over 3. X equals 5/3 is our answer. Make sense? Let's just do a quick check. We don't have to, but I just want to do a quick check. 8 raised to the 5/3. 8 raised to the 5/3. Index would be 3. That's the cube root. What's the cube root of 8? 2 raised to the 5th power. What's 2 raised to the 5th power? Does it work? Okay. All right, I'm going to move on. Number 3. 1/2 raised to the x equals 64. Ignore the fraction. Just look at the 2 and the 64. I've said use the smallest number. What's smaller, 2 or 64? So I'm going to use a base of 2. 2 raised to what power is 64? I'm going to just erase the parentheses. 2 to the 5th is 32. So 2 to the what would you think is 2 to the 6th? And then 2 to the what power would be 1/2? 2 to the -1. And then it's still raised to the x power. Got it? Okay. So I have 2 raised to the -x equals 2 raised to the 6th. I got it down to one base on each side that is the same. I can drop them. -x equals 6. Divide each side. What does x equal? -6. Was there a question? Okay, number 4. 27 to the x equals 9 raised to the 4x plus 1 over 3 raised to the x. All right. I have 3 bases here, a 3, a 9, a 27. I still use the smallest one. Which one am I going to use? The 3, the 9, or the 27? 3. Okay, so I'm going to first change the 27 to a base of 3. What does that become? 3 to what power? 3rd. And the x is still there. Equals, I'm going to change 9 to a 3 to the what power? 2nd. And the power of 4x plus 1 is still there. I'm going to put that in parentheses. And when I multiply, what math word am I looking for? What am I going to do here when I do multiply? Distribute. Later, but when I do, I'm going to distribute. And then in the denominator, that's just going to stay 3 to the x. Okay, everything's now a base of 3. I just have to clean it up. 3 raised to the 3 times x is what? 3x equals 3 raised to the, what is that? 8x plus 2 over 3 to the x. Okay. Now, earlier I said, I don't know if you guys caught it, but each time on numbers 1, 2, and 3, I said you had to get them down to the same base. But I also said you have to get them down to the same base, but a single base on each side. I don't know if you caught that, but I kept saying a single base that is the same. Do I have a single base on each side? I have one base of 3 on the left side, but how many bases of 3 do I have on the right side? And I cannot drop it if I have more than one base. Does that make sense? It has to be one base 3 and one base 3. So am I ready to drop? No. But we just reviewed all the tools at our previous lesson. On the right side, what do I do when I'm dividing like bases? Add or subtract? Subtract. So I'm going to rewrite it as a single base, and I'm going to subtract the exponents. 8x plus 2 minus x. Where is the minus x coming from? From the denominator. Because I'm dividing like bases, I change it to a single base and subtract the exponents. That's how we work them out. Change it to a single base and subtract the exponents. Three raised to the what? 7x plus 2? All right. Now can I, oh, that dropped and it shouldn't have. Now can I drop the bases because there's a single base on each side? Yes? Single 3, they are both the same. Now can I drop the bases and set the exponents equal to each other? Yes. 3x equals 7x plus 2. Subtract the 7x, divide, you end up with a negative fraction. Go ahead and do that now. Do you get negative 4x equals 2? Is that what you guys got? And then what do you get as your final answer? Negative 1/2. Any questions? Okay. Next one, number 5. We have 1/2 raised to the negative x plus 3 equals 8 times 2 raised to the x minus 1, close parentheses, raised to the 4th power. Okay, definitely advanced math type question. Ignore the fraction, just look at the 2, 8, and the 2 as your bases. What base am I going to use? 2. So I'm going to change this 1/2 to a base of 2. I'm going to change that 8 to a base of 2. I'm going to leave this 2 as a base of 2, but I am going to do what with this 4? Distribute. Okay, so 1/2 becomes 2 to what power? Negative 1. And not now, but on the next step, I am going to distribute that negative 1. Okay, 8 becomes 2 to what power? Third. And then right now I'm going to go ahead and distribute 2 to the 4x minus 4. All right, is that what you guys have? Any questions? Okay, I'm going to clean this up. 2 to the, what would that become? Positive x minus 3. Is that right? Positive x minus 3? Now, I should have cleaned up the right side, but I purposely did it just to check with you guys. Is it okay if I drop right now, yes or no? Why not? Because what's going on the right-hand side that I'm not allowed to drop? There's 2 bases. Can I drop if I have more than 1 base on either side? No, 1 base on each side. So in order to drop, what do I do here? If I'm over here I subtracted because I was dividing. Where is it at? Right here. I subtracted because I was dividing. What am I going to do here when I'm multiplying? I'm going to add the exponents. 2 to the x minus 3 equals 2 to the 3 plus 4x minus 4. Where did I get the 3 plus from? This 3 right here. And you combine like terms. Now that the bases are the same, you're ready to drop and do x minus 3 equals 4x minus 1. Subtract, divide, you end up with a negative fraction answer. All right, what did you guys get as your answer? Negative what? 2 over 3. Anybody else get that? Negative 2/3? Yes? Okay, we have one more, number 6. Questions before I move on to 6? Anybody need this up a little bit longer? Not sure if I heard a yeah. No? Okay. 3 to the x times 5 to the x equals 225. Okay. A little bit different, like how do I get these to have the same base? I'm going to change this because I can, because it's multiplication. What is 3 times 5? Actually, I'm going to do this first. Because I can, because it's multiplication. Do you agree I can do that? If I were going to do this, could I distribute there because it's multiplication? So could I pull it out as well? And what's 3 times 5? Yes? And then get them to the same base, 225. Can you check if I can raise 15 to a certain power? Can you check? Is 15 squared 225? Okay, do they have the same base? What does x equal? 2. Any questions? No questions?